Okay, hello, Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to all of you. Okay, as scheduled today, we will have morning class, okay, 8 a.m. to 10 a.m. or 11 a.m. to 1 p.m. Okay, still morning. Okay, so as I have promised before, we will continue our statistics subject. Okay, our statistic lesson with probability. Okay, for those who already have the reference book, okay, statistics for engineers, you can refer to our second subtopic, which is probability. Okay, so previously we have covered the descriptive and inferential statistics. Okay, very basic topic in statistics. Okay, so now we go to a still very basic topic in statistics, which this knowledge serve as a basis, okay, as a basis for you to understand other later topics. Okay, so this topic is quite important, and you also have the basic of probability knowledge, okay, from your high school. So I expect that at least you know how to calculate probability classically. Okay, let's me brief on what are the subtopics lie under this probability. Okay, I refer to your textbook. Okay, if you have your textbooks, you can also look at the contents. Okay, chapter 1. Okay, under 1.2 probability, we will learn the basic notation and definition of the probability. Okay, the classical definition of probability, the mutually exclusive event, additive rule of probability, conditional probability, multiplication rule of probability, and independence. Okay, so from your textbook, there are some subtopics under this probability topic, but we are still in chapter 1. Okay, but in my slide, okay, I will use I have organized some of the subtopics, okay, that will have some flow, okay, to make you understand what are these mutually exclusive, intersection, union of sets. Okay, so okay, let's go together. Okay, so since we are already in week 2, so I hope I will teach more faster. Okay, so okay, this is the outline of our lesson today. Okay, for the first part, I will define, I will give you, I will brief you, okay, I will provide you, okay, the definition of probability generally, okay, and then we go to the basic probability formula. Okay, so in understanding the probability formula, you have to know what is the events, okay, what are events and their complements, okay, and then how these events interact with each other, and then we go to intersection of sets, unions of sets, mutually exclusive sets, okay, dependence and independence of set, and then these all sets are used in additive rule and multiplicative rule, okay, and also involve the conditional probability. So we will go through all these subtopics, okay, together, and if you have some question, okay, you can straight away, okay, ask me. Okay, but I can guess and I expect that this lesson should be very basic and you will understand by yourself. Okay, or you can make some revision from the notes in the internet and from the video that you can find in YouTube. Okay, so I will give you some basic knowledge of the probability. So what is probability? Okay, apa tu probability? What is probability? Okay, probability, basically we define the probability as the likelihood of an event occurring. Okay, the likelihood of an event occurring. So how likely, okay, how likely our event will occur. So before you go further, what is the likelihood of an event? First, you have to know what is the meaning of event. Okay, what is an event? Okay, so an event can be a specific outcome. Okay, it could be a specific outcome, just a single value of outcome, or single outcome, whether a value numerically or not a value. Okay, whether a name, okay, or a string, or a letter, okay, or a combination of several outcomes. Okay, so event could be specific outcome or combination of several outcomes. Okay, so in the slide, as you can see, I have provided 3 simple example of an event. Okay, so let's go to the first one. Okay, so I choose rolling a die. Okay, let's say I have 6-sided balanced die. Okay, that contain number 1 until 6. Okay, and then I want to define my event as rolling a 4. Okay, when you roll a die and then you got number 4, okay, on the top of the die. So I define my event as rolling a 4. Okay, so if you have a 6-sided, the balanced 6-sided die, so when I set my event as rolling a 4, the probability is 1/6. Okay, since we have 6-sided balanced die. Okay, the second example, I define my event as getting a tail. Okay, getting a tail. So let's say we have a coin and then we toss the coin. Okay, so we toss the coin. So since a coin just have 2 sides, okay, just have 2 sides. A coin just has 2 sides, whether a head or a tail. So I want to define my event as getting a tail. Okay, it's depend on you whether you want to define your event as getting a tail or getting a head, because you have to know what the probability that you want to know based on the definition of the event that you have decided. Okay, and then the third example I put here is running a mile under 6 minutes. Okay, so for this example, the outcome could be yes or no, whether all these participants successfully running a mile under 6 minutes. Okay, so based on the examples that I have provided, if you can see all the outcomes, okay, all the outcomes are a specific outcome. Okay, there is none of them a combination of several outcomes. Okay, could you give yourself, or could you tell me, okay, could you suggest what is the event that will give you a combination of several outcomes? Okay, take some time to think. Okay, so okay, let's say we use the same idea here. Okay, the same idea here. I choose the first example. Okay, rolling a die. Okay, when I said an event that contain a combination of several outcomes. Okay, let's say I define here rolling a die. Okay, rolling a die, but I want to define my event as rolling number less than 6. Okay, so we have several number here, several outcomes with 1, 2, 3, 4, 5. So since this experiment, okay, or this trial have several outcomes, so it is a combination of several outcomes with 1, 2, 3, 4, 5. Okay, as long as the number appear is less than 6. Okay, so when you have a clear definition, a clear understanding of an event, so you can easily understand what is the probability you want to determine. Okay, so the use of this probability is, okay, why we want to calculate the probability? So we want to measure the likelihood of an event occurring And then once we can measure the likelihood, we can compare which event is likely to occur. Okay, so to measure this probability, we have to assign some value. Okay, how we measure likelihood? So we have to assign some value so that we can define the measurement, and then we use this value. Okay, after we assign the value, we use the value to compare. Okay, which event is likely to occur. So to compare, we have to have two different numbers so that we can easily compare. Okay, which one is higher, which one is lower. Okay, so we have to assign a number to the probability value. Okay, so probabilities can be expressed numerically. Okay, so probability, since we want to compare the likelihood of an event will occur, we will assign a value, okay, which can be expressed numerically, whether in percentage, okay, whether 20%, 30%, 50%, 60%, or in a fraction form, okay, 1/3, 2/3, okay, 3/4. But conventionally, but usually, but in common practice, okay, we express our probability values from 0 to 1. Okay, so it takes value from 0 to 1. Okay, so as I have shown to you here, the line number from 0 to 1, okay, the possible values of the probabilities, which is from 0 to 1. Okay, when you got the probability is equal to 0, it means that it is an absolute certainty, okay, for the event not occur, because we got the value probability is equal to 0. Okay, and when you got the probability is equal to 1, it means that it is an absolute certainty of the event will occur. Okay, so if you got your value of the probability value like 0.03, okay, it still have the likelihood. Okay, we cannot assume that your probability is equal to 0. Okay, it still have a likelihood, but it is very small likelihood. Okay, so as we all already know, when your probability value increasing from 0 to 1, okay, from 0 to 1, so your likelihood will increase too. Okay, so the higher your probability values, the higher the likelihood of your defined event will occur. Okay, so since we already know the general definition of probability, so now we want to know how to calculate the probability. Okay, the basic probability formula. Okay, so let's say I define my event as capital of A. Okay, capital of A is equal to event. Okay, but you can also use any other letter. Okay, in your textbooks, I think they use capital of E. Okay, it depends on you. Okay, which letter you want to use. So I choose here, I use capital A. I define capital A as my event. Okay, P of A. Okay, P of A is the probability. So how to calculate your probability is equal to the division of the preferred outcome or your favorable outcome, and then divide by the sample space or your all possible outcomes. Okay, okay, we go to one of the example. Okay, tossing a coin. Okay, so in the picture I have provided in the slide, okay, that is a head. Okay, since we have the picture of a head of a man, so it describes a head. Okay, so I define my event A as head only preferred outcome. Okay, I only prefer a head or outcome. Okay, whether we got a head or a tail in the tossing a coin. Now I define my event as getting a head only. So since we have two sample space, because we have two sides of coin, okay, a coin just have two sides, so the probability of A is equal to 1/2. okay, in a fraction form, or you can also write as 0.5, okay, 50%. Okay, so other example, let's say I define my event as A is equal to rolling a 6. Okay, I just use a die. So when I roll a die, I define my event as rolling a 6. So the probability of A is equal to 1 over 6 or 0.167. Okay, so assume, okay, in this all example, we assume that the die that we have used is a balanced six-sided die. Okay, balance mean each side of the die have different value, which is from 1 to 6. Okay, so for the second example, okay, I define my event A is equal to rolling a number that is divisible by 3. Okay, so first you have to know what is divisible by 3. Okay, what are the numbers that can be divided by 3? Okay, so 1 until 6, we have 3 and 6 that can be divided by 3. So our possible outcome or our preferred outcome is 2. Okay, number of possible outcome is 2, whether 3 and 6. So the probability of our event A is equal to 2 over 6 or 0.333. Okay, so this event contains several outcomes. Okay, combination of several outcomes. Okay, and then the third one, I define my event as rolling a total of less than 5. Okay, rolling a total of less than 5. So the probability of A is equal to